Hi class. This is a chemical reaction that will involve some use of the ideal gas law. So if you want to give it a go ahead and give it a try. Again, we're going to start this with the balanced chemical equation. So we need to add some coefficients here. I'm going to just do that relatively quickly. So this is actually some pretty interesting chemistry going on here. Sodium azide at the NaN3 is a component of airbags. So upon electrical current, this will ignite and decompose very, very quickly into sodium metal and nitrogen gas. And this is the nitrogen gas that inflates the airbag to protect you in a collision. The sodium metal then reacts with some other things like potassium nitrate and silicon dioxide to form some inert glass, so like glass of a window. And then, so yeah, let's see if this mass, 126 grams, will produce enough nitrogen gas to fill an 80-liter balloon. Okay, so we need to first balance that equation, which we've done, and then we're going to get on the mole train. So we're going to take 126 grams of the sodium azide and convert that to moles by using the molar mass. All right, and then we get 1.938 moles of sodium azide. Okay, so plug that into your table. All right, now this is an easy one. We don't have to worry about limiting reactant because we only have one reactant, so therefore it has to be the limiting one. So we're just going to then calculate our yield of nitrogen, 1.938 moles of sodium azide. For every 2 moles of azide, we make 3 moles of N2 gas. So this means 2.908 moles of nitrogen will be produced. So if we consume all of this, we are left with 0, and then we would produce 2.908 moles, and then have that many left at the end of the reaction. Okay, so how much volume does this take up? We have PV equals nRT here for us to help with that. We need my pressure, which is 735 millimeters of mercury. All right, we need that in ATM to use the ideal gas law and the particular constant that we usually work with. So we are going to do that conversion. You have to divide by 760 millimeters of mercury per 1 ATM. And so that is a pressure of 0.967 ATM. And then my temperature is 26 degrees Celsius to Kelvin is 299.15 Kelvin. So let's start plugging in. The volume is equal to my moles, 2.908 moles, times R, 0.08206 liters, times ATM per mole Kelvin, times my temperature, 299.15 Kelvin. Okay, and then we're going to divide that by the pressure, which is 0.967 ATM. So check your units, cancel, ATM, ATM, moles, moles, Kelvin, Kelvin. We're left with liters. Wonderful. So the volume is 73.8 liters. So no is the answer to our question. Will it completely inflate the airbag? Not quite. We need a little bit more sodium azide to finish the job there. So we've calculated our yield of nitrogen and the volume of nitrogen, the volume of space that nitrogen occupies. So thanks for watching. Email me if you have questions.